Welcome to Algebra 2. Today we're going to be discussing common logarithms. The common logarithm is a logarithm that can be found in your calculator, so it's the one that has the base of 10. So anytime you just see something written as log of x, so y equals log of x, this means that that base number right there is 10. So whenever that little number is missing, it means that that number there is 10. So we're going to use common logarithms to solve some equations. Our first equation is 3 to the x power is equal to 10. Currently, to the x power, this in the exponent we can't do anything with. We could certainly rewrite this as a logarithm, but this would be a logarithm with a base of 3. And we aren't going to be able to use our calculators to help us solve this. So instead, we're going to take the log of both sides. So we're going to take the log of 3 to the x, and that then should equal the log of 10. So it's kind of like adding a little bit more to the equation and being able to solve it that way. Because here, if we take the log of 3 to the x, we know that this x power using our properties ends up being multiplied out in front, and then we can get it alone. So we're going to rewrite this using properties. So this then becomes x times the log of 3 is equal to the log of 10. And then to get the x alone, you would divide by the log of 3. And now your calculator, you can take log of 10 divided by log of 3. And when you do that, you should get about 2.0959. Typically for logarithms, we always go to 4 decimal places. Alright, so let's look at the second example. 2 to the 7x is greater than 3 to the 5x minus 3. And what we want to do here is we want to take the log of both sides, just like we did in the previous problem. So we would have log of 2 to the 7x is greater than log of 3 to the 5x minus 3. And then once again we know that these exponents using our properties of logs end up being multiplied out in front. So we'll rewrite it like that. So here we'll have 7x times the log of 2 is greater than 5x minus 3 times the log of 3. Notice that 5x minus 3 we want to keep in parentheses because we want to multiply that entire exponent by the log of 3. We need to get the x to one side, so we'll have to distribute that log of 3 throughout. So we will then have 7x times the log of 2 is greater than 5x times the log of 3 minus 3 times the log of 3. Now to get our x alone, we'll have to get the x's on the same side of the equation, so we can subtract our 5x log of 3 over. So we would have 7x log of 2 minus 5x log of 3 is greater than negative 3 log of 3. Notice we can't combine these two together because they're not like terms. This first one is a log of 2, the second one is a log of 3. But keep in mind that this is just some number and that's just some number. So what we can do is we can take these two x's out like it's a GCF. So x and then times 7 times the log of 2 minus 5 times the log of 3 is greater than negative 3 times the log of 3. At this point in time, if you'd like to, you could certainly take this value and figure out what number that is using your calculator. Just make sure that if you do that, you leave it to the nearest 4 or 5 decimal places. But to get the x alone, we just have to divide by this number. So we're going to divide by 7 log of 2 minus 5 log of 3, or if you already figured out what that number is, you can just divide by that number. Either way, you're going to get the same result at the end. So x is 7 log of 2 minus 5 log of 3 ends up being a negative value. So we're going to be switching the sign from greater than to less than, and we should get something around 22.5855. And once again, Remember, these are just numbers. 7 log of 2 minus 5 log of 3, that's just a number, so you can plug that into your calculator. Negative 3 log of 3, that's just a number, so once again, that can be plugged into your calculator. Let's do another example like this one. So here we have 7 to the t minus 2 is equal to 5 to the t power. So we're going to take the log of both sides. So we will have log of 7 to the t minus 2 is equal to log of 5 to the t power. These exponents, using our properties, we know can be multiplied out in front. So that would make us have t minus 2 times the log of 7 is equal to t times the log of 5. We'll have to distribute our log of 7 through that t minus 2. So that would be t times the log of 7 minus 2 times the log of 7 is equal to t times the log of 5. To get our t's on both sides, so we're going to subtract the log of minus t log of 7 over to the other side. So we'd have negative 2 log of 7 is equal to t log of 5. And then we wanted to subtract that t log of 7. Keeping in mind t log of 5 and t log of 7, the log of 5 and log of 7 are just numbers. So now we can take the GCF of our t out. So we'd have negative 2 log of 7 is equal to t, and then in parentheses, times log of 5 minus log of 7. To get the t alone, we can divide by log of 5 minus log of 7. Or, once again, you can just use your calculator here to figure out what number that should be. If you do plug this entire expression in your calculator, these parentheses here are an absolute must, because you want to divide by that whole quantity of log of 5 minus log of 7. But when you do that, you get t to be about 11.5665. Once again, leaving to the 4 decimal places. If you're still not 100% sure on this, there is an additional video with this example on. You can find it the next link down in Willow. So if you would like to see another example, check out this video. Otherwise, go ahead and try it on your own, and you should get p is less than or equal to 4.8188. If you get that, you know that you're doing it correctly. So there's one other thing we want to discuss, and that is we can express any logarithm with any base number in terms of common logarithms just by using this formula. Log base a of n is equal to log base b of n over log base b of a. So the logarithm that we know is base 10, our common logarithms. So for example, if I wanted to express log base 3 of 11 in terms of log base 10, it'd be log base 10 of 11 over log base 10 of 3. That's log base 10 of the number you were taking the log of over log base 10 of the base number. So if we have log base 3 of 20, we want to express it in terms of common logarithms and then approximate it to the nearest 10,000th. So we'd say, well, this should be log base 10 of 20 over log base 10 of 3. And then if you take log of 20 divided by log of 3, because remember, your calculator, the base number is 10, so you could also just write this as log of 20 over log of 3. But if you put this into your calculator, you're going to get about 2.7268. So there is our common logarithms.